never, this is my third time I've been on a Crystal Cruise, and I've never spoken in this venue, so I feel a little bit more like a nightclub entertainer. So what I'm going to try to do is give my entire speech in song. No, I'm just kidding. I will not. But thank you all for being here to talk about a subject that is not only a great passion of mine, but I think it's a topic that everybody, every human being needs to really understand on a very, very deep and fundamental way. And when we open up the papers, we see all kinds of stories, many of which feel very important, like ISIS, like the US elections, like Aleppo, which as terrible as it is. But 1,000 years from now, when people look back at today, they won't think that this was the age of ISIS, and they won't think that this was the age of terrorism, unless the whole world blows up, which could happen, but I don't think it will. But what they will say is this was the dawn of the genetics age. And after 4 billion years of our species evolving from single-cell organisms to the very complex organisms that we are today, for these last 4 billion years, we've evolved by what you learned in biology class, random mutation and natural selection. That's Darwin. And now, for the first time ever in our species, and for the foreseeable future of our lives on this planet and in space and elsewhere, we are now going to be evolving by a new set of drivers, which are guided mutation and guided selection. It will be, in other words, self-evolution, evolving ourselves. And just think about what that means, and just on a fundamental, deep level, how that change is going to impact who we are and what we are. In 1865, Jules Verne wrote a short story about humans landing on the moon. And so in 1865, you know that the moon is there. You know that people travel because you have horse and buggy, and you think, well, wow, wouldn't it be crazy if we could get to the moon? Like right now, you can think of the equivalent of that kind of dream of saying maybe we can have people on Pluto. Like we know that there's travel, we know that there's space travel, we know that Pluto exists. We have no idea how we would get people there, but you could imagine it as pure science fiction. In 1962, President Kennedy gave his famous speech in Houston where he announced, many of you may remember this, when he announced that the United States would land a man on the moon within a decade. And of course, as you know, it took 7 years until Neil Armstrong had his famous one small step for man. So what's the difference between Jules Verne and President Kennedy? When President Kennedy spoke, he knew we had all of the technology. We had all of the mathematics. We had all of the capabilities to get a human being to the moon. What we hadn't at that time done is fine-tuned it, put all of the pieces together so that we could reliably land a man on the moon. But it was a foregone conclusion in 1962 that we would get there. In terms of fundamentally transforming our species, this is not 1865, this is 1962. We have every technology that we need to make this transformation, and these technologies are advancing at an exponential rate. And even if they didn't advance at the same rate that they are, still we would realize this goal in far sooner than I think many of us have internalized. And that's not even counting new tools and new capabilities that don't exist. And I'll talk about what these capabilities are, but just let me put this in perspective. If you had a time machine and you traveled 1,000 years into the past, and you took a baby and brought that baby back to today and placed that baby with a family, that child would grow up to be a normal kid just like any other child. You'd put them in school, you would not be able to tell the difference. Get that same time machine, travel 1,000 years into the future, and bring that baby back to today, and that baby would be, and that child would be a genetic Superman or Superwoman. They would live longer, healthier, a more robust life. They'd be smarter. They'd probably be better looking. They may be more empathic. They may have all kinds of capabilities that we can understand. They may have capabilities that are outlier capabilities right now. So you hear about these 1 in a million people who can, or 1 in hundreds of millions of people who can do all kinds of things, whether it's mathematical capabilities or perception or all sorts of things. So those outlier capabilities will be spread more throughout the population. They may have certain capabilities that right now we think of as that exist in the animal kingdom, whether it could be some kind of special eyesight or different ways of hearing or all sorts of things. Or it could be capabilities that we don't even know what they are and can't even understand them now because they could be created synthetically through synthetic biology. So how are we going to get from here to there? And again, the surprising piece of this is that these are all technologies that in their whatever forms exist today. So let's go through. I'd like to talk today about 3 of them. First, raise your hand if you've heard of in vitro fertilization, IVF. Good, that's pretty much everybody. So you know, with IVF, a woman's eggs are extracted, and then those eggs are fertilized with the man's sperm outside of the body, and then those 1 or 2, and it used to be 3 or 4, of those fertilized eggs are implanted back into the mother. That's IVF. There's an additional procedure that is relatively small now called pre-implantation genetic diagnosis, PGD, or pre-implantation genetic selection, PGS. And what PGS is that when you have those early stage fertilized eggs outside of the mother, you grow them from, well, you know this from biology, 1 cell to 2 cell to 4 cell to? Good. Everyone's on top. 2? 16, good. Anyway, so at roughly 5 days, let's just say that you have average woman having her eggs extracted has 15 eggs extracted, and sometimes it's more and sometimes it's less. So, but let's just say it's 10 in this case. At roughly 5 days, you extract 2 cells from each of those 10 early stage fertilized embryos, and then you sequence those cells. So let's give a little bit of background about genome sequencing. In 2003, when the Human Genome Project came to its conclusion, it had taken more than a decade and cost about $1 billion. Today, to sequence a genome costs $1,000 and takes a few days. So that rate is 2 times faster than Moore's law. In about 5 or 10 years, it's going to take maybe $50, maybe $25, and just take maybe an hour or less. So what does that mean? What does it mean if sequencing is free? It means that right now, when we sequence these early stage embryos, what are we doing? We're screening for single gene mutation diseases. Those are diseases that are implicated by 1 gene, like there's an on-off switch, like Tay-Sachs, sickle cell disease. There's a long list. I think we have probably a lot of doctors on this on this cruise. And so those Mendelian single gene mutation diseases are rare individually, but collectively they are not rare. Right now, we can screen for the gender of the child and hair color and eye color. Still relatively simple things. But as the cost of genome sequencing goes towards 0, we're going to think about genetics in a totally different way that has, in some ways, nothing to do with how we make babies. And that is because genetics will be the foundation of personalized or precision medicine. All right, raise your hand if you've heard of precision medicine. All right, good number. So right now we live in an era of generalized medicine. And that means that there are certain drugs that maybe work well for some people and can kill other people. And the way you find out if you're one of the people for whom it will kill is by taking that drug. You take the Tylenol and you say, oh, I guess I'm one of those 1 in 2 million people who die from Tylenol. Or people who have cancer, and they say, we have this drug treatment. It works really well on 30% of the people. We're going to give it to you to find out if you are one of those 30% people, But there's also 30% for whom it can cause terrible side effects. And that's kind of a crazy way to do medicine. So what personalized precision medicine is that everybody is going to have your sequenced genome as the foundation of your medical record. And before you are doing all kinds of treatments, maybe not every kind of treatment, but all kinds of treatment, they're going to do an analysis of your genetics to say, are you likely to be the kind of person who will respond to this kind of treatment? So when you have genomics, personalized medicine, and electronic medical records, that's the whole point of everything comes together. So you get a treatment, that's tailor-made for you and your individual makeup. Why is that important here? Well, it's important because everybody will have your sequenced genome as part of your electronic medical record, and then we'll be able to track what your genotype, what your genes say, and your phenotype, your experience of life. How tall were you? How old were you when you extracted some kind of genetic disease? What was your IQ? All these types of things that are much more genetically complex than the single gene mutation diseases that I mentioned a moment ago. And then what we're going to be able to do when there are millions and hundreds of millions and ultimately billions of people with their medical records digitized, and we're comparing the genotypes and the phenotypes, we're going to know a lot more than these single gene mutation diseases. We're going to use what are called genome-wide association studies to look at very complex patterns for very complex diseases like type 1 diabetes or coronary heart disease. But when you're looking at these genome-wide association studies to figure out correlations and probabilities, you can understand any genetic characteristic or trait, not just a disease. And so that brings us to the question, well, how genetic are we? I mean, there's this age-old debate about, are we more nature or are we more nurture? And there's no absolute answer to that, but scientists and researchers have used twin studies as an approximation for figuring that out. And it's basically if you have identical twins separated at birth, and you kind of look, well, how similar were they in these different circumstances, or how different were they? And so the rough estimate is somewhere between 50% of who we are is genetic, and the higher end 80. I'm definitely on the higher end, because the more we understand about genetics, the more of these things that seem to be either magic or nurture, we're finding more and more genetic correlations to even things like basic personality traits and all sorts of things. And most parents who I speak with say, when my child was born, I knew right away that they had a sunny disposition. That's not nurture, that is nature. And so when we understand more of what the genes are saying, let's go back to the embryo selection, the PGS. So the woman has her eggs extracted. Those eggs are fertilized. They're grown to roughly 5 days. The cells are extracted. The cells are sequenced, and the sequencing costs next to nothing. And then we don't just have information. Does this child have Tay-Sachs or sickle cell disease, or is it a boy? We're going to be able to know within a decade roughly what the IQ of that child is going to be, provided that they have a loving home and good food to eat and things like that. We're going to know within a couple of years how tall that child is going to be. There are all kinds of traits and characteristics that we are going to know. And everybody, one of the reasons why my last book, Genesis Code, was featured in Cosmopolitan magazine, is that I met the editor, Joanna Coles, at a party in New York, and I said, you guys should really do something on my book. And she said, well, what's it about? And I said, knowing my market, I said, it's about the end of sex. She goes, wow, sex, that's what we read about. What do you mean? And I said, well, when we're going to be able to use embryo screening to eliminate most genetic diseases, having children, procreating through sex, is going to seem like a radical act, like a lifestyle decision, like being a Christian Science monitor or the people who aren't vaccinating their kids. It's natural in a way. I mean, people have a right to do whatever they want, but it's going to be seen as a fringe behavior, like not vaccinating children, not the normal behavior it is today. And when everybody is screening, because people are going to want to eliminate a lot of these in some cases, very terrible genetic diseases, then we're going to have a lot of other choices in jurisdictions where it's legal for parents who are comfortable making that choice. So parents will be able to choose, do I want to have a child that has a very good chance of living a long and healthy life? Because you'll have these 10 embryos, fertilized early stage embryos, and one or two are going to need to be implanted. And we're going to have all of this information. And you may say, and it's a legitimate choice, to say, well, I just don't want to know. But if you do want to know, it could be that there's a projected 20-year difference of lifespan, a different probability of getting early onset Alzheimer's, a different chance of being a mathematical genius, of being a sports genius, of being a sports star. Anything that has a genetic foundation will be a choice. And by the way, I'm doing a whole nother session on this topic as a conversation, because whenever I can see on everybody's faces how worried people get. So we're going to do at the end of the cruise, we're going to do a whole conversation session that we're all back and forth. And so people will make those choices, and those choices will be normalized. The making of those choices will be normalized in the beginning because governments and insurance companies will be incentivized to provide this kind of treatment because it will be far cheaper to screen out genetic diseases than it will be to do what we are doing today, which is provide lifetime care for all of the people born with those diseases that will then be seen as preventable. So that's number one. That's this first stage of where I believe we're going. Now, the second stage is breaking the logjam of human female hominin egg production. The average male ejaculation has hundreds of millions of sperm. I hope we're allowed to say that on Crystal Cruise. But the female, as I said, average egg extraction is about 15. But I think all of you have heard about stem cells. So stem cells are cells, embryonic stem cells that can become any kind of cells. Now there's a cell called an iPS cell, an induced pluripotent stem cell. And what that basically means is there is a way of taking any cell, but it's usually a skin cell or a blood cell, and reverting that cell into a stem cell, and then you can turn that cell into any kind of cell. So turn blood cell, let's say, into a stem cell into an egg cell into an egg. So now instead of having 10 eggs, you can have 1,000. You can have 10,000. Let's call it 100. So you have 100 eggs. And then because you have unlimited supply of sperm, you fertilize those 100 eggs. And then because the cost of genome sequencing is zero, moving towards zero, you sequence cells from each of those 100 early stage fertilized pre-implanted embryos, and then you get a readout. And it says, here are your 100. These 10 are likely to have or will have Down syndrome. These 15 are likely to get early onset Alzheimer's. There's a 60% chance that these 5 will be mathematical geniuses, or that these 2 will be star sprinters. Anything that has a genetic foundation, we're going to be able to, for the more complex things, just predict, and for the simpler things, declare. And so what will that mean if you are in the process of selecting which fertilized eggs, early stage embryos to implant when you have all of that information? And then there's another level of this, and that is right now, human beings are very slow to reproduce. Like fruit flies, it's like you're born, you mate, you die. I'm sure if you're a fruit fly, it feels like a long time. But for us, it's like you're born, you have all those developmental stages, then you go to middle school or high school, and you kind of have your first date, and you're really awkward, you don't know what you're doing, and then you go to college, and you kind of run around. Don't run around in college, young lady. And then you have a relationship out of college, and it tends not to work, but you learn some valuable lessons. Then you meet the right person, and then ... So all of a sudden, you're like 28, and then you're having a child. It's like it's a slow process. But what if you could mate early stage embryos with each other, which again, technology that already exists. So you're having children when you are 10 days old. Now you could go through 1,000 years of evolution in 2 years. And what will that mean for speeding up the process of evolutionary change in our species? And this brings me to the really radical science. What these two things that I've said, those are, are the more basic. But raise your hand here if you've heard of CRISPR. Raise your hand if you've heard of CRISPR. Okay, so CRISPR is something that everybody should know. And what it is, it's the CRISPR-Cas9 is a new technology that allows scientists to do precision editing of genomes. And so just imagine you're at your computer with a Microsoft Word document and you have a sentence. And let's just say that this sentence is GATC letters, but it could be any sentence. You just take your cursor, you go to a certain place in that chain, and in this case, it's in the genome, and you cut where you want to cut. So it's a pure cut and paste, the exact same as you would do with word processing. And then you can just leave that cut, you can add a letter, and so just to go back to the genome, you can cut the genome, you can add genetic material coming from someplace else, you can turn on a gene, or you can turn off a gene. And this is not a new capability for human beings, but this level of speed and accuracy and cost is truly unprecedented. CRISPR, the application of CRISPR, is as revolutionary of a technology for our species as harnessing of fire and harnessing of steam, in my view. Bigger than the jet engine, and it's happened in all of our lifetimes. And so what does that mean? It means that we're going to be able to do all of those things that I talked about in the beginning of my talk. We're going to be able to fundamentally change the genetics of ourselves, excuse me, and of our future children. And this science is already underway. Last year, there were 4 studies in China using CRISPR to alter the DNA of non-viable pre-implanted embryos. Research is happening in the UK now, again, on human embryos that haven't been grown to term. There's lots of research. I mean, CRISPR is one of the hottest fields in biotechnology, but lots of very promising research about using CRISPR to very aggressively and very successfully fight cancers with gene therapy, where they take out T cells and manipulate them to boost their ability to fight cancers and then put them back in people's bodies. There are experiments where using CRISPR to knock out sickle cell disease. So these technologies, which are growing very, very fast, in some ways they're very frightening to people, and they should be. On the other hand, they're extremely exciting, and they also should be exciting. Because I talked about that kid coming back from the future. Like, who wouldn't want some of those capabilities? Who wouldn't want to live longer or healthier? Who wouldn't want to be 80 years old or 90 years old and feel like you're 20 or 30? I think these are all things that we want. Who wouldn't want to have cancer and not have these incredible technologies that can be used to fight or eliminate that cancer? Or who is a carrier of some very painful and difficult disease like Huntington's disease or mitochondrial disease would say, I'm a natural person, so I want to give my children, my grandchildren, my great-grandchildren, and on down the line, this disease, which is this lottery where they may die before they're 10 because I love nature so much. And this is a little secret, but nature sucks. We're human beings. The entire history of our species is about fighting nature. When we were living by nature, we lived to be 20 years old. We were starving to death all the time. We were scrounging for calories. We were being eaten by wild animals. Like, nature stinks. The things that we call nature today, like organic corn, there's nothing natural about them. Those are all of our creations. Like 12,000 years ago, find me corn. You couldn't. You could find a weed with a few kernels. We've created this world. And so I think there's a fetishization of natural, which I think it gets in our way sometimes, but it's also good because I think we need to have a very, very healthy level of respect for the delicate ecosystem that is the world. But it's going to be very, very difficult to let me see how we're doing, to maintain that kind of balance because there will be a lot of pressures pushing this technology forward, these technologies forward. One of them will be that within societies and between societies, there's going to be a lot of competition. That we are, in the not distant future, people are going to be able to have children with a lot of advantages because of decisions that were made at the time of conception, or just beyond the time of conception. And that's going to create a lot of pressures. And that if there are people who have, let's say, a 20 or 30 point IQ advantage over their peers, how are we going to think about that? Or if somebody has a natural child who gets some kind of quote unquote natural child who gets some kind of preventable disease or is born with some kind of at that time preventable condition, will that person's neighbors and friends say, well, that was a decision, a legitimate decision that person made? Or will we tend to see them like now we see the anti-vaccination people? Like when their kids get measles, nobody says, well, they were natural and measles are natural, therefore, c'est la vie. People think, well, geez, how many scientists do we have who've told us that we need to immunize our kids? And they made a conscious decision not to immunize their kids. That's kind of like it's terrible, it's a tragedy, but that was a lifestyle choice. And so we're going to have these competitive pressures are going to push individuals forward, families, communities, and societies. But on a national level, there also is going to be international competition that has the potential to really take all of this to another level. And that is because just different societies have different foundational beliefs. There are many people in the Western world, in the Judeo-Christian world, who have a conception of God as like a watchmaker who's kind of here tinkering and creating the world in 7 days. And we haven't always thought of it this way, but and so when people do things that mess with that world, even people who are secularized Westerners feel on some gut level uncomfortable. And that's why we've seen with genetically modified crops this, in my view, somewhat crazy response. Because people feel it just in their gut that there's something wrong with genetically modified crops. And you could have, which is the case, basically every Nobel science winner in history signing petitions saying that this fear is unfounded. It's not that there aren't issues with GMO crops, it's just the ones that people are afraid of aren't the right ones. But people just have this gut feeling, and even people who are making an argument that climate change is real because every scientist in the world says it's real will say that GMOs are bad, even though every scientist in the world says that they aren't. And the reason is, at least in my view, is people have this feeling that something is natural and something else is not natural. And that feeling is different across different societies. And so in China, and I'm giving two lectures on China and Asia geopolitics next. In China, there's a cultural view, and certainly under this current administration, that the world is malleable. It's a system built by engineers who are comfortable with population engineering through the one-child policy, environmental engineering, the Three Gorges Dam and the massive south to north water diversion project, comfortable with taking kids away from their families and placing them in Olympic sports schools for the glory of the state. And so in that kind of culture, will they have the same reservations, the same hang-ups that we have about natural and unnatural? Well, the early indications are that will not be the case. But what will happen, and this will happen sooner rather than later, when people in some other society, whether it's China or someplace else, or on a ship on the high seas, decides that they're going to start manipulating next generation humans to give them all kinds of new capabilities, will those of us who live in countries that aren't comfortable with those changes make it illegal for our citizens to procreate with genetically enhanced humans? Will we do genetic screenings of every person who's coming into our country? I don't know the answer to that, but I can bet that it's going to be a big and very, very complicated issue. And as I can see on all of your faces, there are lots of really tough, really challenging issues that all of this raises. And there are issues of equity. I mean, who will get access to these technologies? I talked about there are some democratizing pressures, like the elimination of genetic disease, but it can't be, it won't be, that everybody has access to these technologies at the exact same moment at an equal level. So what will it mean from an equity level that there are maybe, for some period of time at least, genetic haves and have-nots? And we've seen from the history of European colonialism, if one group has just a tiny advantage, like a better ship or a slightly better weapon, they can leverage that advantage into global domination relatively quickly, and so it becomes self-perpetuating. What about diversity? Our greatest survival skill as a species has been our diversity. And that's why when conditions change, there are people who were the superstars of the old system, and it turns out that they don't have the skill set for the new system. But because we have so many different types of people, when the environments change, then a whole new set of people get to be the superstars, get to lead our species. But if we start making decisions based on what we feel is good now, and through cultural norms, and people say, well, I want a kid who's going to be a mathematical genius, let's say, and everybody does that. What happens if supercomputers make human mathematical genius irrelevant? I mean, I could imagine a day where a supercomputer could do better at even the most abstract forms of math that our most creative mathematicians are exclusively doing today. And then people who have these great math skills will be like Morse coders. Like if you meet somebody who says, oh, I'm the world's best Morse coder, you don't think like, oh my God, that's incredible. You think like, well, that's kind of a fun, quirky little hobby you have. And so these diversity issues are extremely important. And morality, whatever that means, and we all come from ancient traditions. We're all constantly inventing our own traditions. But this science won't develop in a vacuum. People are going to bring themselves to the debate, bring themselves to the conversation. And even our own traditions have different approaches to the application of these kinds of technologies. And so we're going to need to really do a lot of thinking. And what I always say is that the technology is new, but the values that we will need to deploy to figure out how best to optimize the benefits of the technology and minimize the harms, those aren't new values. We need to draw on the best of the values that we already have. But the problem that we face is that while the science is advancing exponentially, people's thinking, in part because of the structures of our brains, is only advancing linearly, and the policy and regulatory environment is only inching forward glacially. And so there's this massive mismatch, and it's extremely dangerous. And I talked about about GMOs. When genetically modified crop technologies were being developed, the scientists then thought, this is so great, we're going to save hundreds of millions of lives. Let's just do this. I mean, who wouldn't understand the benefits of what we are unleashing? And yet today, as I mentioned, people have such a strong emotional response to GMO crops that it's almost nothing can be done. And now is the time if people were worried about GMOs, imagine how they're going to feel about GMHs. But now is the time where we need to have an inclusive global dialogue on these technologies and what they mean. Actually, just last week I was meeting with the team of the incoming UN Secretary General, and they've asked me to put together a strategy, which is one of my to-dos on this cruise for how to do this. But this is what we're talking about here is not just some kind of arcane policy issue. We're talking about the fundamental future of our species. And that's why this isn't just a topic for experts. It's really a topic for everybody. And the reason why I'm so passionate about speaking about things like this, is I need to enlist all of you into this conversation. This is your conversation. And so I've been thinking for a lot of years about, well, how can we bring people into the conversation? Because when you start talking about science, people have this fear. People like, oh, I didn't really like science when I was in high school or whatever. Not this gentleman here. You seem to be on top of things. But a lot of people have this fear. And so I've been thinking a lot about, well, what are ways that we can bring people into the conversation? So I write nonfiction. I do a lot of lecturing, which I enjoy. But I'm also, and this comes back to here, I'm also a novelist. And we are human beings. Traditionally, we learn by telling stories and telling stories around the campfire. That's our history of our species. So I've written my last two novels, Genesis Code, which is about the future of human genetic engineering, and the novel that came out 2 months ago called Eternal Sonata, which may be relevant here. It's about the very real science of extreme human life extension. Actually, I live in New York, and I run a series at the 92nd Street Y with the same title as this, Homo Sapiens 2.0. And we did the last one that we did was with the top professors at Harvard and Albert Einstein on the science of life extension. And it's very, very real, and a lot of that is also in my book. And so what I'd like to do, I started to keep looking at my watch. We just have a little bit of time. What I'd like to do, and the way I've structured this, is to raise these ideas with you now, and we have a little bit of time for a couple of questions. And then after this thing, I'm going to be in the bookstore and in the apropos shop, and if you'd like to come and talk, that's where I'll be. But also, if you'd like to pick up my books, it's funny, last year, on the cruise, and I do one cruise a year because I enjoy it, I said, I've written a book. I'd love for you all to read it if you'd like. I don't actually make any money off of writing books, but if you would like to read my book and the cost of the book is the only thing getting in your way, please just go to the store and put it on my room tab. And these women went running there, and they put it on my room tab, and then people who had bought the book called and complained, and I heard that they're giving them away. I demand a refund. So unfortunately, I'm not saying that this year, but if you'd like to read, both books are in the bookstore, and here's my suggestion, is that I'd love for you all over the coming week and a half to think about these issues. You can read my books if you like, you don't have to. Talk about it with each other, and then on our last C Day, we're going to do a structured conversation that I will lead on these topics, because again, I happen to be up here speaking, but we are all the speakers in this process. This is about us, it's about our children, it's about our grandchildren, it's about the future of our species, and that has to be something of the utmost relevance to all of us. So with that, we've got about 5 minutes, so just some preliminary thoughts and preliminary questions, and then I'll be in the apropos, and then let's keep this conversation going. Yes?
I have 2 questions.
Yes.
For decades, I've heard that we were going to have, by the 80s, if you lose an arm, you'd be able to sequence an arm.
Yeah.
And that seems like we need to flourish. We have
Right.
And the second is, I'm a little concerned about the upcoming generation with the lack of concentration on prolonged tasks because of the immediacy of gratification that they get through computers and so on. So
Yeah. So I'll repeat those questions. I know it's hard for people to hear. The first is we've been hearing about regeneration, that when a starfish gets its arm cut off, it grows back. When a human gets his or her arm cut off, it doesn't grow back. And then secondly is the short attention span of young people in the computer age, which I hate to, I don't want to be too political, but we have just elected in the United States a president with a shorter attention span than the most hyperactive of high school kids. So we'll see what that means. But in terms of regeneration, again, there's an idea of exponential change, which you all understand intuitively, and that's that if you have a penny and you double your penny and then you double your 2 cents, very, very soon you're a multi-gazillionaire. And exponential change applies to information technology through what I mentioned earlier, Moore's law, which is computing power roughly doubles every 2 years for the same cost. And so people understand intuitively what exponential change is in the IT realm. And the way you feel it is you just have an expectation now that your iPhone 2 years from now is going to be smaller, better, faster. It's going to have all these new capabilities that seem pretty cool and that weren't possible 2 years before. What the Human Genome Project did is it transformed, and the sequencing of the genome transformed biology into an information technology. So we are code. We are made up of code. And when you think about what are the qualities of information technology, those are now the qualities of us. We're understandable in a way that if you wanted to understand code, you could take it apart and you could look at that code. And they get it if there are people who are spiritualists or religious people, they may not agree with what I just said. And what it means is when we see ourselves as made up of code, we're hackable. We're changeable in a way that we wouldn't have appreciated or wouldn't have understood before. And so that brings me to your question about regeneration, is that when you're on the thing, when you're doubling your pennies in the beginning, I had 1 penny, now I have 2 pennies, now I have 4 pennies, now I have 8 pennies, I feel really poor. But when you get to the J curve, it goes up very rapidly. And that's what we're seeing with artificial intelligence now. There was a thing called the AI winter, when everybody was making all of these promises and it wasn't happening. And now, in the last 2 years, all of a sudden, AI is just going crazy. And I think that with all of these things, and I certainly think regeneration is one. I mean, regeneration gets in our genetic code because fingernails regenerate, hair regenerates, teeth regenerate once, but not twice. I mean, like, why? And my guess is that for all of these things, there are just these little small genetic triggers that we haven't quite figured out. But when we have 1 billion people, when we have 5 billion people with sequenced genomes and electronic medical records, all of these, more and more of these secrets are going to be revealed. And it'll happen on a faster and faster pace. And that's what exponentiality is about. In terms of attention spans, on one hand, since the beginning of time, I'm sure every generation has thought that their kids were kind of going to hell because they had something that the parents did that the kids don't. And I write novels, and so I think it's very valuable for people to kind of go through a process of learning and growing. But I think that generations have different skills and capabilities that make different types of things possible, and that so I don't really have a good answer to your question. For me, I definitely think that it's great to stick with things, and this kind of jumping around, in my mind, seems a little dangerous, but there are things that are made possible by that jumping around, by the multitasking, that maybe are different possibilities than would exist with what we have. I'm not happy with that question, but with my answer, I'm sorry, but that's just a preliminary thought.
If you're a cardiac patient and you have somebody with a 10-minute attention
Yeah, you should find a different doctor if your doctor has a 10-minute attention span. All right, so we got time for one more final question, but again, at the end of the cruise, last sea day, we're going to have a whole session about conversation. And for those of you who'd like to read one of my books, I think it'll give you some useful background. Do somebody there? Yeah, just very, very quickly, and then you very quickly, yeah.
What you have told us today is most interesting and very enlightening for me. It is how to run life, I guess.
Yeah.
Now, it seems to me We have now, we had 150 years ago, 3/4 of a billion people.
Yeah.
Today we have 7.5 billion.
Yes.
Predicted to be
Yeah.
10 billion by 2050.
9.
Right now
Yeah.
we have wars about
Yeah.
food, water, people, millions of people are starving and all the rest of it. Now
Yep.
if we follow, if scientists and yourself follow through with your theories,
Yeah.
we can have more people.
Yep. So let me just in one sentence, and then we'll close up.
This can be applied to things other than human beings.
Yes.
It can be applied to diseases,
Diseases.
to other beasts of
Yep.
various kinds.
Yeah.
What do we do about that, sir?
Yeah. So overpopulation and applications of these technologies. I'll answer them very quickly, and then we'll have an entire session at the end of the cruise to talk about them. With overpopulation, we have the resources right now to feed and clothe everybody on Earth. We make a value decision how to allocate those resources. And the most educated populations are the ones that are the societies that are having the fewest kids. So I definitely am not that concerned about overpopulation or lack of resources in the future. I'm deeply concerned about the values that we bring to bear today, and if we use those same values in the future, where we haven't internalized. We don't feel a global responsibility to make sure that every human being, because they're a human being, has access to basic minimums. And so any issues that we may have in the future, which are very real, we also have today. And I think we need to be focusing on those things now. In terms of your question, which is very legitimate, we're already using these technologies like CRISPR to change animals, to change plants. And there's a very real danger of synthetic pathogens. I mean, bioweapons, one of the reasons the U.S. intelligence community is focusing on this issue. As a matter of fact, I'm going down to Washington to consult with the Defense Department on this, is that there is a real danger. And these technologies can provide, in military terms, offense and defense, but historically, offense always has the element of surprise and the upper hand. There's so much that we could talk about, and there's so much that we will talk about. So please think. I'll be in the apropos if you'd like to talk more. And then let's all please come together at the end of the cruise. And we'll have a very, very different structure without me talking the whole time, but with everybody engaged. But I just wanted to lay this foundation as a start. So thank you all so much.